All right, now we can get started here. So let's see. Here we are. We're covering part 2 of chapter 7.2. You're using inverse norm. Now, last week, you were using normal CDF. So, key thing here is you are given an interval and you're asked to find an area in the curve. What do? You use normal CDF. That's what you're doing there. Then they switched things around. They gave you an area under the curve and asked you to find the interval. What do? You used inverse norm. Now, the big shift, the big concept in statistics was when you got to chapter 8.1 and you had to wrap your head around this crazy concept. If you repeatedly took random samples from the same population, and from every random sample you got a sample mean, what would the distribution of all those sample means look like? And that's your focus of chapter 8.1. And what you saw was that if those sample means were doing a good job of representing or estimating the population mean, they'll cluster around them. And when they cluster around them, they take on a particular shape. And they take on a center and a spread. And you're looking at the distribution of all the possible sample means you could ever possibly get from repeated sampling. And that's why it's called the sampling distribution of the sample mean. So I just want you to know, really understanding the sampling distribution of the sample mean is the foundation for all of the statistical methods we're going to do for quantitative data. It's kind of a big deal. It's really important that you wrap your head around it and that you don't confuse it with a population distribution like you were working with in chapter 7.2. All right, let's go ahead and close that down. Get rid of our silly gay comic here. All right, now we're going to go over something here. Now, this is going to be a little unusual, so just let you know that. However, what we're going to go over next, there's actually going to be an assignment attached to it. So only those who watch this video or the recording of it will be aware of it. So just so you know that not only is it, I consider it to be very valuable information for you, but there's an assignment attached. So let me get this thing fired up and start it from the beginning. All right, now just so you know, this is a little presentation I've given to all 3 of my other face-to-face classes, and I don't want you to be left out. Just so you know, about a year ago, you know, when you're an instructor and a professor at a university, you get to research what you're interested in. So about a year ago, I started looking into what fascinates me, which is what we have learned in the past 30 years about how the brain works, which, by the way, most of what we know about how the brain works has been discovered in the last 30 years, along with the controlled experiments that have been done in finding out which study techniques have been proven to be the most effective. And this has a lot to do with that. I just came across this last summer. It was created by Dr. Sandra McGuire. I bless her heart. I think she's a genius in what she pulled together here, and I'm going to share it with you. Oh, I've altered it a bit for this class, but really, she's the genius behind this presentation. So let's talk about, well, what is this presentation anyways? Well, for this statistics class, most of you are in one of these career tracks. Most of you, simply because this class is a prerequisite for it. And if you are in these areas, then this class is extremely important because it's going to ensure that you get one of those jobs that pay you for your ability and not just your GPA, what you can actually do. Well, we're going to see that the students who happen to attend this session that I'm sharing with you finish the course with a B average versus a C average. And we're talking about the entire group. So you know there's variability involved with that. That the entire group actually did better on their exams. So I just want to share with you, now on the left there is Sandra, who put this thing together, and they've won awards for what they've done here. And I think they deserve it too. In fact, they even got a presidential award for what they've created, what you're going to see here. So what exactly did they do? Well, basically, they made a lot of students' dreams come true. Look here. Now, you see that the 4752, those were the midterm scores for Travis before he heard this presentation. After he heard this presentation, takes what, 45, 50 minutes? That's all it took. And look what happened to his exam scores afterwards. Why, he did significantly better, actually ended up with a B in the course in spite of, look how he started out in his psychology courses. Look at Joshua as a chemistry student. Now this was a semester, so that's why it counts for all the exams, but he was bombing midterm after midterm. But after he heard this presentation, what you see in red, those were his scores afterwards. He actually ended up with an A in the course. Pretty impressive considering how he did on the first 3 tests. Dana, the first-year physics student, did okay the first test, but really bombed the second. But after hearing the presentation, it was pretty sweet after that, got an A in the course. So that's why I am waited till after you had your first test to give you this presentation. You see, the reason why is what you got on your first test really doesn't matter. What matters is what you do from this point on. And after this point on, maybe that'll be changed after you hear this presentation. We'll see about that. So what we're going to do is we're going to share with you what the most impactful strategy is that you could do. And the most important mistake most students make that cause them to get less on their exam scores than they thought they understood is how they're doing their homework. So let's go over that. Well, first of all, we want to become expert learners by using metacognition. So let me lay out exactly what this is. So let me ask you, now, when you've done homework, have you ever done this where you're working on a homework problem and you're going, I'm not sure how to do this. And what did you do? You flip back in the chapter or scroll back since you have an online book and you found an example. And you just use that example following its steps in order to help you solve your homework problem. Have you ever done that? Well, chances are you have. Most people have. Well, you see, here's the problem with that. That would be a wonderful way to study if your instructor or professor, when you got your exam, also gave you worked out solutions to refer to as you work on your test. But that's not what happens, is it? No, it's not. That is why you have got to train your brain for what it has to do when taking an exam. So that's what this method is that we're going to do. Okay, so it goes like this. You're going to be reading the chapter, say lecture notes, also the textbook, whatever it is you're reading. But when you're reading it, read it as though you're going to be given an exam on it the very next day. Do you notice how you focus a little more intently when that happens? Yeah, that's the idea. So as you're reading along, you're bound to come across an example, a worked out example. Now, when you come across a worked out example, what do? Do you skip it? Well, if you do, you got lots of company. A lot of people do. But what I want is for you to commit to never skipping another example from now on. To which you say, what? Yeah, that's right. Because you know what those examples are? They're your brain's best resource for demonstrating that it can do problems without looking at an example. So here's how you do it. You're reading along very intently. You come across that example. All right, cover up where they've done the work, just so you can just read the question, and then you are going to solve that problem. Get out a piece of paper, start working on it, and solve it until you get an answer. You say, but what if I get stuck and feel I don't know what to do next? Well, you just power through it till you get an answer. That's right. Put your big boy pants on and get the job done. You got to get an answer. Push yourself. Then once you got your answer, compared to the answer, without peeking at what the work they did, compared to the answer of the textbook, and if it's the same, then and only then can you look at what the textbook did. But if your answer is different from their answer, then you got to go back to your work and figure out, where did you make your mistake? That's right, you dig and you dig till you figure it out. Now, the idea is, don't give up too soon. Spend at least 15 minutes, just thinking, what can I do next? What can I do next? Pushing your brain to think of all what you could possibly do next and figure out, well, what is it I did wrong? Now, here's a question. When you made a mistake at this point, are mistakes good or bad? Hopefully, most of you are thinking, well, I think at this point they're good. And if I asked you why, maybe you'd come up with some good reasons, such as, well, it's not going to cost you. You're not going to lose any points. And that's right. But also, if you make a mistake here and you correct it, where are you not going to make that same mistake? On the exam. That's right. So that's what you're really focusing on here. Now, by the way, we hear a lot of people say, when they get their exam back, oh, I would have done so much better on the exam, but I just made careless mistakes. Have you ever caught yourself saying that? Well, if you did, you're not alone. The vast majority of us have said that. But what we say is, when you really think about it, there's no such thing as a careless mistake. Mistakes only look careless in retrospect. Because look, once you know what the right thing is, then the mistake you made looks careless. It's all in looking back in retrospect. But the most important thing to remember is, mistakes are things that have to be made when you're learning. They do. And if you don't make them during this process we're sharing with you, well, you're going to make them on the test. So that's why this technique is so incredibly effective, because you're making the mistakes now. Like when you're agonizing over, okay, well, what do I do next? You'll be making all your wrong turns there, realizing the wrong turns, and you won't be making those on the exam. And this, where you're really pushing yourself. Now, probably, if I had seen this over a year ago before I look into all the research that's been done, I might be tempted to think, I don't know, that might look like a lot of wasted time, just coming up with wrong answers. Maybe that's not good use of the time. Well, I want you to know, now that I know better, from what I found out, this really pushing yourself to try and come up with what needs to be done. Now remember, you've read intently the material beforehand telling you how to do this. And you're pushing yourself, so quite often you'll come up with it, but even if you don't, really pushing yourself to try and remember is an incredibly effective way to learning. Now, this was surprising to me because I thought testing yourself, trying to remember, all that was good for was seeing what you remember. Well, I was wrong. Amazingly, it has a huge effect on your actual learning. So please don't discount this just because you don't quite get why it works. Because, I was in the same boat over a year ago. But really, this is really taking effect of what we have learned about how the brain works. All right, let's see here. Now, after you've done this, now this is all before you've done the homework. Now you can go ahead. After you've read the chapter, worked all the practice problems, you can start the homework. Now you could do 2 or 3 homeworks before you go and perhaps look back at an example to make sure you're following all the steps and everything's going well. But I want you to realize, now it may have been slow going, working through the examples, trying to figure out the answers, but once you went through that, worked through all the mistakes you made, I think you're going to find when you're doing the homework, it goes a lot faster than what it used to do for you because you've already gone through this. And then when you're doing the homework, you're just reinforcing, reassuring you've learned from the mistakes you made here. I'm telling you, there is a lot of learning going on here in this particular method. In fact, I just want to share a little story with you. Now, way back, now this is a long time ago, I'm talking about 30 years ago, I was taking upper division statistics class, and it's 3 terms. The first term is probability, the next 2 terms is statistics. First term, got a B. Sure, I was disappointed, but B's are a good consolation prize. But the second term, boy, I was in trouble. I got a C in that class, and I got a lot of C's in the other classes. Things were looking pretty grim for me. Now, let me ask you, if you got a B in the first term, you got a C in the next term, and if I didn't do anything different, where was my grade headed for that third term? Are you saying a D? Well, I agree with you. And I realized that. So I knew I had to do something different, but I really didn't know what. So I just kind of tried something that came to mind, hoping that it would be an improvement. Well, just by dumb luck, what I picked happened to be an extremely effective learning technique, like what I'm going to be sharing with you here. And I was just lucky because, all this stuff that you're seeing here, this wasn't around 30 years ago when this happened to me. But I lucked out. This one technique I used resulted in me in that following term, I got an A in that class. In fact, I got the highest score in the 2 midterms. And in all my classes after that, well, I was striving for all A's, but I always ended up with 1 B, all A's and 1 B till my very final term. I finally got all A's. Then I worked on my master's degree, and I got my 4.0 all the way through that. Just by coming across one effective technique. And you know what? I'm going to share several with you here. And if I were sitting here with you and I had that one technique I already had, I still would have benefited from this presentation because I could have learned more efficiently. I could have learned faster. This one technique I just showed you, I would have loved to have known this one. I would have been able to learn the material faster than what I had. I was learning it well, but I could have learned it faster using this one. And I got some more to show you that would do the same thing. So hang in there in case you're thinking of zoning out. You're getting some valuable information I wish I had. I got by well, but I could have gotten by even better. Now, what I showed you earlier was anecdotes. Those are just individuals. Well, here's what happened. Dr. Sandra McGuire, she before test, she actually shared these techniques. So what happened was she had a lot of students who applied them and a lot of students who said, I don't need that. Actually, that comes up later. I'm sorry. We had, because this would be like yesterday when I was giving my this session to my face-to-face classes. You know, some people were absent. Well, I guess they're in the control group. And those who attended are in the treatment group. Well, let's compare them. So remember, this presentation came after the first test. So on the first test, both groups are pretty much the same. Really, there's no significant difference between them. But what happened after the presentation? Well, those who were attended, well, the average of the entire class, we're talking about the population mean, increased significantly. What about those absent? Well, it dropped a little. It's still basically the same, but it certainly didn't increase like it did those who attended. And then after that, well, of course, they kept using the techniques and they increased even more as their semester, because they were on the semester system, went on. And the entire class, even though the entire class on exam 1 was down there at 71.65%, ended up with 81.60%. That is a huge percentage increase just by attending this one 50-minute presentation. Those who are absent pretty much just hung around, stayed there right at that low 70%. So it's a whole grade difference just by being present for this one presentation. So I'm glad you're here for this one. You know, sometimes the significance was even more because for another semester, well, those who were absent, instead of staying at that low 70%, they slowly dropped down till they ended up with a D. But those who attended, once again, even though they started down there at that low 70%, kept increasing till they got up to this level. But now you can see, oh my gosh, it was a 2-grade difference. So going on down here, these are the desired outcomes we're looking for you. First, we want you to think about how you're currently doing what you're doing in this class. Then we want you to consider, well, see the difference between what you have been doing and what you need to start doing. And we're going to give you, in this session, the concrete strategies you need to use for the remainder, it says semester, I meant to edit that, for the remainder of this term, not semester, and use them in Math 243, but you know what? In all your other classes too. Why don't you mind? Might as well get A's in all your other classes too. What the heck? And the idea is you'll become a more efficient learner. Now you see, this is the benefit I would have had. I could have learned more efficiently. I could have gotten the job done in less time. Now, sometimes we hear students will say, oh, I studied for hours and hours and hours, and I still didn't do well on the test. You know, all that just means is they're not studying efficiently, and we're going to take care of that in this session. Make sure that that doesn't happen to you. Now, I got a couple reflection questions for you. Now, the first one is, what's the difference, if any, between studying statistics and learning statistics? Then the other reflection question is, for which task would you work harder? Would it be to, if I told you, you got to make an A on the next test. Let's say we got in 3 weeks, we're covering this chapter and this chapter, and on that next test, you need to make an A, or at least nothing less than a B. Or if your task was, all right, here's what we're going to do. On the day before the test, we're going to have a review session. And you're going to have to stand up in front of a classroom, and you're going to have to teach that information. Students have any questions, you're going to answer them and get them straightened out. So which of those 2 tasks would you have to work harder for? So going back to the first question. Now, when I was doing this in my lecture classes, what I did was I told them, all right, I want you to think about this for about 10 seconds and then introduce yourself to your neighbor and share your ideas with each other. Now, because we're an online session, you can't do that, but I'm just going to pause for a while and let you think about what do you think about that first question? Just the first question. We'll get to the second one later. All right. So what I would normally do in my lecture class, I would say, all right, do we have any brave souls willing to venture forth and share what they think? Now, before they did that, I gave them I prefaced it with a little bit of information. I told them, Dr. Sandra McGuire, who's been, she's been giving this very presentation for a long time now throughout the United States. So she has asked this question literally to over 10,000 people around the country. And in some places, there have been a few people who have said they thought it was exactly the same thing. So, of course, I asked, is there anybody in this group who would say studying and learning are exactly the same thing? Well, after hearing that, no, they're not. So then I asked them, okay, so what do you think the difference is? So then, I'll listen to their ideas. Now, the most common answer, the most typical answer we get is, and it's a good one, studying is memorizing and learning is understanding. In other words, studying is just trying to memorize the information for a test or quiz. It's short term, it's tedious. Oh, I hate studying. But learning is when I'm understanding what's going on. I'm not going to forget it in 2 weeks from now. I'm going to remember it. And that's a very good summary of it. Now, what's important for you and for all of us, it's extremely important that we make the distinction so that the strategies that we're going to be talking about are strategies that will result in your learning and not just studying. All right, now let's for the second reflection question. And in my class, what I would usually do is I say, we'll just do this by a show of hands. And I'll say, okay, for those who would work harder in order to make an A on the test rather than teach the material to the class, how many would work harder to make an A on the test? And I would let those people raise their hand. And then I'd say, okay, how about for those who had to teach the material? Who would work harder for that? Then you raise their hands. And typically, way more people will raise their hand for option B, teaching material. And to which I would agree. Because, if you kind of teach the material, you don't know what questions they're going to ask. All you know, they're probably going to be the hard questions, and you really got to be on your toes. Whereas, if you're just studying to make an A on the test, well, you're just kind of focused on what's going to be on the test. I just want to know that. Make sure I kind of understand it. And that's really different from having to be ready for any possible question that those students are going to ask of you. Let's go over here. So, for which test would you work harder? Hopefully you'll say, teach the material. So, to ace Math 243 and everything else, remember, these techniques will work in all your other classes. In other words, you could get A's in all your other classes using these techniques. But you got to stay in learn mode, not study mode. And study as if you have to teach the material, not just to make an A in the grade. Now, studying as if you have to teach, let me tell you, why does that work so well? Well, has this ever happened to you? There's been something that you just totally understood, But somebody else didn't, so they asked for your help and they want you to explain it to them, so you gladly did because you're a nice person. So there you are, you're explaining away when all of a sudden, probably mid-sentence, you stop because you go, oh, wait a minute, I'm stuck. I thought I understood this, but I'm stuck right here. Has that ever happened to you? Well, it probably happened to a lot of us if you've ever gone to try to explain something you thought you totally understood, and you didn't quite understand it like you thought you did. What you have to appreciate is you never would have known that you didn't understand it if you hadn't gone through the process of explaining it. You're able to uncover the things that you thought you totally understood but didn't. And then, of course, what do you do then? Well, you go back, look it up, and get that missing piece and clear up that misunderstanding, what you were missing. Now, if you hadn't caught it here, where do you think that would have been found out and exposed? Yeah, during an exam. So that's why it's so valuable, because, it's so subtle. Because you wonder, now, how do I know I really understand this rather than I just think I do? Yeah, practice teaching it. Now, the beauty of teaching is you don't have to have people there. No, you don't. You could just have empty chairs. You could have stuffed animals, maybe creepy dolls, or just imaginary friends. But you just practice teaching it. Now, why is this all so gosh darn important? Well, now I know some of you just are recently from high school, and what we have to appreciate is the difficulty level between college level and high school level, particularly, like, say, stats, high school stats. Well, definitely in college, the course moves faster. Well, we cover in a term. Well, typically in high school, you have a whole year to cover it. The material is conceptually more difficult and cumulative. Problems are more involved. In those tests, they're less straightforward and require you to apply several concepts at one time. So what we're going to do is we're going to use metacognition to become an expert learner in statistics. So that begs the question, what's metacognition? Think of it this way. So up above your brain is another big brain looking down on your brain. And it's looking down there, and it's asking questions like say for looking down on my brain, is asking, hey, what's Larry doing down there? Is he just memorizing, or is he actually learning? Can he actually teach this stuff? And maybe the report comes back, Larry, he's just memorizing. Oh, and not only that, he's copying examples to help himself with homework. Well, that big brain on top of go, oh, Larry, you got to stop that. So you stop that, and you need to practice teaching this stuff. So metacognition, you think about your thinking. Not only is it monitoring, but you're controlling your mental processing. So like Larry, who is going astray, well, the metacognition gets you back in line. It's really answering the question, now what do I got to do to get where I want to go, which is get all A's. Also, to accurately judge your level of learning. And the great way of doing that, as we saw, was to practice teaching it. Now, what we have here is Bloom's taxonomy. Now, you may or may not have seen this. As a general rule, most students have it. And these just shows the difference level of learning. So down here at the bottom, we have the lowest level, and as we go up are higher levels of learning. So with remembering, that's just plain old straight memorization. They ask you what this and what that, and you from memory, you can just blurt it out. You could give me any definition that they ask you for if you're at remembering. But if I asked you to explain in detail, to clarify that, to be able to explain the concepts to someone else, say to your 80-year-old grandmother in terms she could understand, or your 8-year-old nasty nephew in terms they can understand, using analogies that relate to their life, you're able to explain it to them so that they can understand it. Well, that's understanding. That's definitely a level higher than just remembering, which is just memorizing. Now, if you're at applying, well, you can take all this information down here and apply it to solve problems you've never seen before. Now, I'm not talking about problems that look really, really similar to what you saw, but maybe different, but really you're able to apply what you learned here to these other things. And it can be a bit more of a stretch, but you're able to apply all these concepts to multiple different situations that this information would apply to. Then another level higher is analyzing. And if you're analyzing, you could take any concept, break it down into simpler concepts. And those simpler concepts, you could like take 3 minutes just explaining how they relate to each other and the parts above it and the parts below, how it all fits together. And then another level higher is evaluating. Say you could look at 2 different ideas, 2 different processes, determine if one is more likely to be correct than the other. Then going on up even higher, you got creating. Well, now you can come up with your own ideas about solving different kinds of problems or different kinds of processes. So that's the hierarchy. Now, here's what I want you to do. I want you to go think back to high school. And I hope that's not a painful memory for you. But think back. How high up in this hierarchy did you have to go in order to get A's and B's back in high school? So in my lecture class, I would say, okay, just raise your hand. How many people found that all you had to do was go as far as remembering? Just straight memorization. You got A's and B's. And, some hands will go up. Then I would ask about, okay, let's go up to understanding. So how many of you, the highest you had to go was understanding, and you got A's and B's throughout high school? And a bunch of hands go up. And then I asked about the others. Now, as a general rule, this is what Sandra has found, who's done this so many times, is the majority will say that remembering and understanding, though, that's all they needed for most people to get A's and B's in high school. So then I said, okay, now let's shift over now to the college level courses. How high do you need to go? So I say, okay, definitely it was higher than this. Let's go up to applying. How many have found that applying is just as far as you need to go to get A's and B's in your college level classes? And so some hands go up. Then I'd ask about analyzing, evaluating, and creating. Now, consensus is, when this has been asked many, many, many times, the vast majority say, well, in college, it needs to be up to analyzing. So we can see that in high school, it was about understanding, but now in college, it needs to be analyzing. So obviously, in college, we need to kick it up a notch in order to get the grades we want to get, as good as what we got back in high school. So, well, how do you do that? Well, use what we call the study cycle. So here's another method we're going to share with you. It goes like this. Oh, by the way, now this is if you're going to a typical face-to-face lecture class where it's always being lectured. And so we'll explain it in that format. Now, first thing you do is you preview before class. So let's suppose before you go to that lecture, that what you do is, and this only takes 10 minutes, you preview so that go to your textbook, you skim the chapter that's going to be covered, you note headings and boldface words. If there's a review summaries, oh, that is golden. Really go over those. And chapter objectives. Now, those are really valuable. And come up with questions you like. And you say, well, now, why are we doing that? Well, what we've learned about our brain is it can learn and grasp information from a lecture so much easier if it has a framework beforehand. And that's what you're doing here. You're getting a framework. Sort of think of it as a skeleton. Okay? And so then during the lecture, when you're getting the information, you know right where that information goes. You're putting the meat onto the bones. Or you say, oh, no, Larry, I'm a vegetarian. You got to come up with a different example. All right, we can do that. You got a nice, tidy closet. And as soon as you get the information, you got the perfect hanger to hang it on, keeping everything organized. Your brain loves that. It can put everything into its place and everything's organized as it gets the information. Now, if you don't do the preview, it's getting all this information and it doesn't quite know what to do, and it's got to try and figure out how to organize it, and that's a lot more work. So what students have told us is when they do the preview, they find, oh my gosh, the lecture makes so much more sense. Well, that's because their brain didn't have to put so much effort in trying to organize it. It was able to take that information, put everything in its organized place. So you do the preview. Of course you attend class, and you should find that you're getting so much more out of it. But right after class, or as soon as you can afterwards, you want to review the material that you just heard. Has this ever happened to you? Have you ever seen a movie more than twice or more than once? In other words, twice. Well, when you saw it the second time, did you see things that you never even noticed the first time? Most people do. Well, it's exactly the same way here. When you were attending the class, your brain saw certain things. But when you do the review session, you are drilling down and you are seeing things that you didn't see before. And you know what? They're usually really important things that you would see on the exam. Okay, so that's why it's really important. Another reason is when you're doing this, you just attended class, it's in your short-term memory, and you want to get into your long-term memory. Well, that's going to be a lot easier for you to do if you do this review after class very soon afterwards. The more closer it is to when it happened, the easier it's going to be for you. Now, of course, that's not enough. You're going to have some intense study sessions that you're going to follow up with. Now, so you want, do 3 or 5 of these short study sessions per day because, you got multiple classes, so, you're going to have to do more than one of these. But first, just take a minute or two to set a goal for what you're going to accomplish in that study session. Then 2, you're going to study with focus. Focus. Where you're working on your stuff. Maybe applying some techniques you've seen here or whatnot. Now, what's very important is after that session, you reward yourself. Now, some say this is actually possibly the most important part because you're trying to condition your brain to expect a reward after focusing so hard. You'll find that if you keep that up, you're going to get better and better at focusing intently during these study sessions because your brain is going, oh boy, I'm getting a reward afterwards. So it doesn't mind. It puts in a little extra effort in focusing in on the material. Now that reward is, it's whatever it is. What I like to tell people is if they have a nasty habit of procrastinating, they say, well, before I do my homework, I want to do this, this, and this. Well, this, and this, let that be your reward. In other words, your metacognitive mind is looking down and saying, no, you're going to let that be your reward, and you're going to start your intense study session now. and you'll just get in the habit of that. And then, of course, you'll really relish your little reward because you earned it. Look how hard you studied. And then, of course, after that, then take time to review, to go over what you just studied once again, because you're drilling down and getting things reinforced. All right. Now, effective metacognitive strategies, of course, always solve problems without looking at an example or the solution, as we said earlier. It's also memorize everything you're told to memorize. So what if I told you to memorize so far? Well, those crazy symbols. If you don't memorize those symbols, you're in a world of hurt because you won't even know what the answers are that your calculator's giving you if you don't know what those symbols mean. And every time they're used, you're going, let's see now, what does that mean? And you're fumbling along. So you just make 3x5 cards, carry them along with you, and maybe you're waiting in line for a sandwich. Well, just pull them out and review one more time. You will memorize it. Just use flashcards. Always ask why, how, and what if questions. Now, if you think back to Bloom's taxonomy, you know, that very lowest level we had, which was the remembering, that would be the what's. You know, what's this and what's that. But the next level higher, understanding, now that's getting into the whys, hows, and what if questions. And here's an interesting thing. The author of this, Sandra, she said one of the most interesting answers she heard to the question, what the difference between studying and learning, was that, well, when I'm studying, that's the what's. And when I'm learning, that's the whys, hows, and what ifs. And I noticed that if during an exam, if all I've studied are the what's, and I can't remember them, I can't recreate them, and of course I get it wrong on the test. But if I know the whys, hows, and what ifs, and I forget the what's, I find I can recreate the what's because I know the whys, hows, and what ifs. You know what? That is so true in statistics, as you're going to see later on. Then, of course, test understanding by giving mini lectures on concepts. So you can find out, do I really know this or do I just think I know this? Now you really, and this is, notice my calendar I give you, spend time on statistics every day. That's important. The people who let 2 or worse, more days go by without looking at it, it doesn't work out well. Look at it every day. Use the study cycle with intense study sessions. Also, aim for 100% mastery, not 90%. And let me ask you, do we study a little differently when we're studying for 90% mastery versus 100%? What do we do differently? Well, most people say, well, you skip stuff. You know, if you're studying and you're looking at something, you're going, oh boy, that's going to take a long time to get that down. Oh, that looks hard. And then we say to ourselves, oh, it's probably not going to be on the test. And is it on the test? It's always on the test because the faculty want to know who did 100%. So always, always aim for the 100%. Now, I want to show you another tool, and this is a particularly good one for this class, concept maps. Now, in all your other classes, you can just go to the chapter contents of your textbook. You got the title of the chapter, you can put that in. Go through and get the primary headings, then put in the subheadings and any secondary subheadings. You got the structure of your little chapter map. And now this is the value of this. Now, sometimes if it's a big chapter, you might have to tape 2 pages together. Well, that's not a problem. But what you then have is you got a picture, a big picture of the entire chapter, how it all fits together. Then use this. Just pick a random circle like this one here. And then be able to practice explaining, teaching this to someone. How, say, this circle relates to this one over here and the one above it. Now, why do we go to this circle and not that one? And in terms of this circle, how does it relate to these little rectangles underneath? And how does it really relate to this very top part here? In other words, you can explain how all these parts interrelate to each other. And if you look at Bloom's taxonomy, you know that is a not very high level mastery that you would have if you could do that. Now, let's suppose that you're getting two things confused with each other. Maybe this has happened already. Are you perhaps confusing when do you use normal CDF versus when do you use inverse norm? Well, if you are, you better do a compare and contrast chart like this one. So, how are they similar? Well, let's see. Okay, I'll actually write in on this one. Just to give you an idea how you might use this. So, let's suppose you're saying, okay, sometimes I use that function normal CDF on my calculator, and other times I use inverse norm. Now, how are they similar? Well, you notice I use them whenever I have a normal distribution or population, and I use them when the population mean is known and the standard deviation is known. In other words, they give us an actual value for those, like that. So that's how they are similar. Now, how are they different? Well, with normal CDF, in order to use that, you're given an interval. So when you read the problem, they'll actually will use a data value. And that's, now, what proportion of this population is less than this data value or greater than this data value or between this data value and that data value? And you're asked to find the area under the curve. Well, that's exactly what normal CDF does. You give it the interval, and it'll give you the area under the curve that's within that interval. So what's the deal with inverse norm? Well, why don't you just switch these around? Because here, you're given the area under the curve. Now, when you're given an area under the curve, if you recall, if you've read the chapter, and I'm sure you have by now, maybe not, it's either in the left tail or the entire area is in the right tail or it's centered in the middle. It's one of those three. But once you're given the area, you'll make a sketch to get a rough idea of what it's equal to, and then you're going to find the interval that goes with it. Like that. Now, so that's how you keep that straight. So let me clear that. Now, when you cover chapter 8.1 this week, you're going to have to keep two things straight from each other. And this might be a great way to do it. Now, you have already been working with population distributions. Let's see, where's my pen? Okay. Whoops. Try and get, okay, so I'm over here. So how are they similar? Well, let's see. Let's go up here. Let me clear this off. My drawing thing's a little hard to see on here. All of a sudden, I don't know why. Okay, good. Marking things up here. There we go. Let me get my clearing. Gosh darn. This is hard to see after a bit. There we go. So say for concept 1, you put under there the population distribution. Under concept 2, put the sampling distribution for the sample mean. Then you'd say, well, now how are they similar? And you say, well, they have a shape, center, and spread. And so you could have that, but how are they different? Well, a population distribution is the distribution of all the data values, whereas the sampling distribution for the sample mean is the distribution of all the sample means. And you'll make a note of they have a very different spread. Oh, sure, they have the same center, and they'll probably have the same shape, but they're very different in spread. But anyways, compare and contrast is a very, very valuable tool. Okay. Now, this next one. Which one of the next 2 slides more accurately describes your actions before a test? Now, what Sandra did is that before the first test, she actually shared with them all these learning strategies. Well, a certain proportion of students said, oh, pshaw, I don't need that. I all know how to study. I don't need Sandra's silly advice. And other students took it to heart and applied it. So there were a lot of students who did well, a lot who did poorly. So she gathered up the top 5 answers for those who did not do well in her general chemistry class, and what they thought would attribute that to. Well, number 1, didn't spend enough time on the material. 2, started the homework too late. Now let me ask you, if you're starting the homework the night before it's due, are you going to be able to use that technique where you can get yourself to work through all the practice exercises before doing the homework? Probably not. All you're focused on is getting it done, and therefore you have just thrown away your brain's best resource for demonstrating it doesn't need examples to refer to in order to solve the problems. In fact, you've thrown away a lot of really good techniques you could have used, all because you started the homework too late. So that is a really bad thing to do. You see, haven't I kept saying to you, don't put the homework off till the weekend? Well, I hope you appreciate it a little more why it's so bad. Didn't memorize the information I needed to. Quite often students will start off with honorable intentions, but they just didn't get around to it. Look, just go down to the Dollar Tree, get yourself some 3x5 cards, make your flashcards, carry them with you, and use them. Problem solved. They did not use the book. Well, you've got the online version of the book. You got to use it. So remember, that technique, reading intently as though you're going to be tested on it the next day. When you see an example, don't look at their work. You're just going to solve it yourself. And because that's how you're going to learn from your mistakes. Assumed I understood the information that I had not, that I read and I reread it, but I didn't actually practice it or apply it. Okay. Now, this is important because this is actually a study technique that's been found to be not very effective, yet when you're using it, it sort of feels effective. And that's where you read the chapter, read it again and again, and as you do that, it feels more and more familiar, and you think you're learning it. It sort of feels like you are. And it turns out it's not effective. So just know that that's not an effective learning technique. And I'm sure glad I didn't pick that one 30 years ago when I was in the predicament that I was. Now, for those who did well on the test, you ask, well, what did you attribute your success to? Well, they did that preview review before every lecture, did a little of the homework at the time, because when you're working through those examples and spending 15 to 30 minutes figuring it out, that takes time. So they just kept hacking away at it. But of course, once you get that done, Then when you get to the homework, it goes quite a bit faster because all the work you did were those practice exercises. They used the book, did the suggested problems. Oh, and by the way, the practice exercises. So if you're using the learning modules, and oh gosh, I hope you are, you notice I always give you practice exercises with the solutions posted. Why, that's exactly how you could be using those. Working to figure them out yourself after you've read the lecture notes, and then compare your answer with that to see if you did them right. So you've got lots of practice exercises you could be using. And they're all in your learning modules. Of course, make flashcards of the information be memorized. They found that very successful. And most importantly, practice explaining the information to others. That's huge. So it sounds like they were doing the right things. So the question you need to ask yourself before exam 1, which group did you most resemble? You don't need to answer it to me, just answer it to yourself. Now, get the most out of homework. Now this is a little reprise. Let's summing it up. Start the problems early, just like the little calendar I give you, spread it out, and then you'll have enough time to spend on it. Don't flip back to see example problems. You know, I give you lots of practice example exercise and learning modules. Don't open up the solutions because I've got the practice exercises separate, so you don't even need to cover up the solution. But work them through yourself. Don't give up too soon. Remember, you're working on it, you say, I can't think what to do. Well, you just push on through. Yep. So like if I were working on it, I say, okay, Larry, put in your big boy pants and push on through till you get an answer. Keep pushing for at least 15 minutes till you get an answer. Now, if it's getting up to 30 minutes, well, then I guess you got to raise the white flag and give up and then take a look. But you're going to make a note to yourself you didn't do it, and you're going to have to come back to it at another time. But this gives you an idea of how much you're pushing yourself. Now, if you're using tutorial centers, because on campus, on the first floor in the library, there's a math tutor center. Office hours, study groups, if you have anything like that. Before you're doing that, try yourself to understand the concept, work the problem by yourself. Come prepared to ask questions. Be able to explain how you understand the material to the tutor and the instructor. Now, here's a challenge I have for all of you that watching this or watch the recording. And that is all of you. And I'm talking about the population mean. If you were to apply just one of these techniques, all you need is one. You can apply more than one, but really, if you just apply one, do you think that all of you could have a population mean grade point average of 3.6? Does that sound too outlandish? And no, none of you, not a single one of you, getting a grade point average less than 3. So you notice I'm talking about applying these techniques not to just this class, but to all your classes, so that your grade point average for a fall term, absolutely not less than 3.0. And for all of you, if I took the population mean, it'd be 3.6. Do you think you could do it? When I ask the class, some think they can, but there's a lot that go, I don't know, Larry, that sounds pretty outlandish, pretty far-fetched. Because you remember, you got to have commitment to your personal self, but also the group, because you're saying, but if I don't do well, I'll drag everybody down because this is the mean, not the median. Well, I know you can do it. And how do I know you can do it? Because Sandra has done this time and time again. All she asks is, maybe you don't believe you can do it, but who is willing to try? And if everybody hands goes up, she says, that's all we need. Just that you're willing to try, and that's the magic that happens. And what inevitably happens when she's done this, they've made it Sometimes they've gone even above. Or if they didn't, they were really close. But what definitely happened was they did way better than if they had never attended the session. And here's a little information here from when she did do that with that class. So, what can you do starting now to pursue your 4.0 this term? 4.0, well, isn't that what you're going to aim for? I hope so. Well, you're going to spend more time studying. Now, a class like this, it is reasonable to expect 2 hours per week for every 1 hour in class. He said, but this is an online class. Okay, so let me give you an idea. So my class only meets twice a week for 2 hours. So that's 4 hours. So you should be expecting to be doing 8 hours outside of class. Of course, you're not getting the 4 hours that we're spending in class. So really, the lecture class is spending about 12. So if you're about 6 days a week, couple hours, and you're using these extremely effective techniques, you are going to truly master this material. And if you were in any of those areas I showed you at the beginning, where this class is a prerequisite, you're going to go on to that class fully prepared to be successful and learn the successive statistical methods. Aim for higher learning levels and 100% understanding. And of course, if there were office hours, well, for office hours, we have these study sessions where you can ask questions. And if you get together a study group, by all means do so. Use the study cycle. Oh, some of the people or students who saw the study cycle, they call that the power hour. So yeah, use the power hour along with those intense study sessions. The idea is use metacognition. That's where you're always asking yourself, what can I be doing to get this done? You're monitoring yourself and controlling your behavior to study smarter. Okay. Now, it's called course journal number 2. Let me just change that. It's actually an assignment I'm going to give you. This is a very easy writing assignment, and you'll just submit it to me. And in fact, let me just alter this, because I don't want to call it course journal, dude. Let's call this the special assignment. All right, that's much better. And so let me get back to right there. Whoops. Special assignment, and that is what strategy. Now, you only need to pick one strategy. One is all it takes. If you want to do 2, fine, but really, you only need to do 1. So you're going to tell me which strategy you're going to commit to implementing, and you're going to use it for the next few weeks up through your second midterm to see how it works out for you. So it's not a long commitment. You're just willing to do this for the next few weeks up through exam 2. Now, the important thing is, if you don't start implementing this new technique within the next 48 hours, you probably never will. So go over this and decide which technique you're going to do. Write it up. Not much to write. You could just send it to me as an email. It's that simple. Just send me an email. Use the subject heading, special assignment. I'm going to use this strategy. That's what I'm going to commit to. Or maybe, we'll have you be honest. Maybe you say, no, Larry, put me in the control group. Let me be the one in the group that just doesn't do so well because I'm not willing to do this. Because you know what? I don't want you doing this unless your heart's into it. If your heart is really into it, then tell me which method you're going to use. But whether you say you want to be in the control group or into the winning treatment group, no, I'm going to give you points for this. So you're going to get credit for it. Okay? So that's it on that special little session. I want to take some time, of course, to hit on some high points, because otherwise you're going to say, hey, what's the deal here, Larry? I came in here to see how to do the homework. Well, let me show you what I've got for you. Now let's make sure. Oh, I better get into my student account. Hold on here. Let's see. Whoops. It's a little backwards. Let's get in here. Usually I'm already got this logged in, but I failed to do that this time. Wait, this doesn't look right. No, I guess it's all right. Good. So I'm going to go down here to external links, files from the live lectures. Click on this chapter 4 session. Now let's take a look at this. Now, for when you're using inverse norm, you want to follow these steps. Let me say that to the desktop and then open it up. And it steps you through. Now these are the steps you want to do. Like when you're doing the practice exercise, it's critically important that when you're given an area under the curve, you make a sketch of it. Now there's only 3 ways it can be. It might be entirely in the left tail, entirely in the right tail, or it could be centered in the middle, like this example. So you go ahead. They say middle 90%, then by God, just shade in what looks like the middle 90%. But you got to find out what's in the tails. And how can you do that? Well, remember, the entire area under the curve is 1. So why don't you subtract 0.9 from 1? And that difference is what those 2 tails would add up to. And they're equal to each other, half here, half there. So the difference between 1 and 0.9, well, you divide it by 2 and you know what's in each tail. And then, of course, put that in your sketch. So if you have 5% there, 5% here, 90% there, notice it adds up to 100%. So you do that first. You know, your area shaded in and all the regions figured out. And once you got that, then what you're going to do is realize, well, I need to find this lower bound and this upper bound. Now, how do I find that lower bound? Well, what does inverse norm do? It gives you a point on the number line. All it needs to know is the area to the left, the percentile rank, and the center and spread. See, well, I've got all that. The area to the left here is 0.05, and the mean and standard deviation, center and spread's been given to me. So you could fill all that information in to get that. How about the upper bound? Well, what's the area to the left? Well, I've got this 90% plus this 5%. Why, that's 95% to the left, 0.95. That's right. So for your upper bound, you use inverse norm, 0.95, and then whatever the center and spread is. And you've got the lower bound, upper bound that contains the middle 90%. And then what I recommend you do is, and I'm giving an example here. Let's suppose the lower bound came out to 62 and the upper bound came out to 88. Practice writing your answer out like that. And that you're saying that the probability of one randomly selected data value being between 62 and 88 is 90%. And you say to yourself, now look what I did. this middle 90% was given to me, and I was able to use inverse norm to find the interval. Hey, you know what you might think? Couldn't I give this interval to normal CDF, and it should give me this area? It will. Now, of course, there'll be a little round off error, but it will do that. So that's what you want to keep reminding yourself. If I'm given an interval, then normal CDF will give me the area under the curve. If I'm given the area under the curve, I'm going to have used inverse norm to get the interval. And you just keep running that through your head. But at the end of this document, you probably might want to make a nice big image of this picture right here, because this sums it all up. In fact, you know, that compare and contrast, this would be a good image. Look, you're going to be given one or the other. Either you're given an area under the curve or you're given an interval. It's one or the other. Okay, so if you're given the interval, what do? Follow the arrow. Oh, that's right, I use normal CDF, and it gives me the area under the curve. But what if I was given the area under the curve? What do? Follow the arrow. You use inverse norm to get the interval. And of course, you use the interval and use normal CDF to get back to the area under the curve. You take the area under the curve, use inverse norm, get back to the interval, and on and on and on it goes. But that way you can see the relationship between them, and you won't have to be asking anybody the question, hey, when do I use normal CDF? When do I use inverse norm? The answer is, what were you given? What were you asked to find? What were you given? What were you asked to find? So that's the first thing you want to get down and comfortable with before moving on to chapter 8.1. I'm going to close that. Now for chapter 8.1, which is a very important chapter, you're going to go to the learning modules. And in fact, why don't I go over to the tutorial DVD, go over to lecture notes, get over to chapter 8.1, and read intently as if you're going to be tested on the next day. You got that? Yes. So read intently, reading along, getting straight. You know about the population distribution, the distribution of all the data values of the whole population, distribution of all the z-scores. But now, what about the distribution of all the possible sample means you could ever possibly get from repeated sampling? Well, over here, now you could play this movie and it'll demonstrate how to use this Java applet here. But first, watch the movie and it'll help you visualize this theoretical concept of how the shape, center, and spread that all the possible sample means will take on if you keep repeatedly sampling over and over again many times. A pattern develops, and it is the foundation for all of the statistical methods we use for quantitative data. So it's important you understand it well and you're not confusing it with a population distribution. Yeah, you could do a compare and contrast map for that, like I showed you. And the spread for a population distribution is a population standard deviation. But the spread for a sampling distribution is known as the standard error. So that's a new concept you'll be wrapping your head around. But once again, really kind of go through this and play around with that Java applet to try to really understand what a sampling distribution is. And it takes time. And that's why hopefully you've started on the work now. You're working on it every day, because if you were to put this off till the weekend, it's not enough time. And you know, Starting the work late is a losing strategy. Hopefully you appreciate a little better now, because if you do that, you can't use the winning strategies you just learned about. So get cracking. All right? So let's leave it at that. I've pointed you in the right direction. You've got the resources here to get the job done. You've got examples worked out for you, because in the learning modules, you got practice exercises with the solutions posted. You use those before you start the online homework. And you'll find that the online homework doesn't take that long. If you're taking a long time on the online homework, that means you didn't do the preparation work that you should have. Okay? All right, so that's it for this session. I know this session was different, but I hope you found that it was helpful. You probably won't realize that until you actually practice. Okay, until next week.